it is a total distance here. Okay, so if for one particular edge, it can be taken as 1 by 14. Okay, similarly for one particular edge in S2 can be considered as 1 by 31. Okay, so this is this values. Okay. Next is now pheromone deposition on each edge. So how to calculate on each edge? Okay, so C1 and C2. Let me consider the C1 and C2. Okay, here not only S1 travels, here S2 also travels, because you can observe that C1 and C2 where S2 travels, whereas here C1 and C2 S1 travels. Okay, so both of them they travel. When there are two ants traveling on the same route, then the pheromone deposition will be higher. So how to find that higher is like just adding up between C1 and C2. Since there are two ants that is traveling on the same edge, then their summation of the deposition will be the total deposition of the pheromone in that particular edge. That is like 1 by 14 is for S1 and 1 by 31 is for S2. Just sum it, you'll get the total deposition of the pheromone in the edge between C1 and C2. Similarly with C1 and C3, but see here in C1 and C3, this is C1 and C3. Okay, S1 will not travel in that path, but S2 travels in that path. So only one ant is traveling towards that path. Hence, we are considering only the S2 value here. Okay, so this is the overall pheromone graph representation for this particular instances. Okay, so this is like here only S1 travels, so it is 1 by 14. Here S1 and S2 travels, so it is a 1 by 31 plus 1 by 14. Similarly, we'll calculate for all other edges. Okay, and this is its value. Okay, like point values, a decimal value. Okay, so this is a pheromone deposition without considering a evaporation coefficient or evaporation. Okay, now we'll find a pheromone deposition with respect to evaporation. So here we'll consider the evaporation constant evaporation rate. Okay, so this is a formula like I of G with respect to particular ant. So it will be like 1 by rho, where rho is a evaporation coefficient. We'll say that if 1 is the deposition, a pheromone deposition in that particular edge, then half of it will be evaporated. So here evaporation rate will be 0.5. And here Ij means pheromone deposition between I and J means it's an initial pheromone deposition. That pheromone will be considered as a 1 in a constant way. Okay, it's a constant. It's a 1. Okay, then we'll add with the actual pheromone deposited from all other ants. Like that is, this is a pheromone deposition between I and J with respect to K ant. Okay, so it may be 1 or 2. If there are 2, then we'll add up. Okay, 2 different pheromone deposition, and then we'll make a final pheromone deposition in that particular edge. Okay, so here I already told that this will be 1 tau of Ij, where here coefficient, evaporation coefficient is 0.5. Okay, we are considering as a 0.5. Okay, so now we'll substitute the value. So for the path C1 and C2, there are two ants moving. Like we'll find that even S1 is traveling and as well as S2 is traveling. See here, C1 and C2, S1 also travels, whereas S2 also travels. So the pheromone deposition between the C1 and C2, where S1 and S2 both travels, will be this formula, where 1 is as it is minus rho is 0.5 into tau Ij. It's an initial deposition of pheromone, that is 1, plus summation of all the pheromone deposition done by different ants. That is, since S1 and S2 are considered, so it will be a summation of S1 and S2. Okay, this. So this value give the total pheromone deposition in a C1 and C2. Similarly for C1 and C3. So same 1 minus 0.5 into 1 plus here C1 and C3. C1 and C3 here only second ant is moving, first ant is not moving, so the pheromone deposition is only based on the second ant. So here 1 by 31, it's only based on a second ant. Okay, so this is a pheromone deposition. Okay, and this is a overall graph, like we just calculated the value and we also represent it in the decimal form. Okay, so this is a complete graph of pheromone deposition when considering the evaporation coefficient. Okay, so this is done. Next, how to select a edge. For example, if there is some salesperson starting from C1, then how to find the probability of that C1, that particular ant select C2 or C3 from C1. Okay, that's how edge selection comes here. Okay, so this is a formula where Pij means probability between the city C1 and C2, means the probability of a particular ant moving from I means C1, for example C1 to C2, that is J. Okay, will be given as this pheromone deposition of I and J to the power of alpha, where alpha is constant here, we are considering it as a 1, and Nij power beta, where Nij is the same, the total deposition that we consider as Lij, like here the same way we considered 1 by 31 and 1 by 14, so that will be a value here Nij, okay, between that particular edges, sorry, that particular setters. Okay, where beta is a constant. Okay, so whole divided by summation of pheromone deposition between I and J to the power of alpha into the value between that two edges I and J to the power of beta. So it will be summation, so it will consider all other summations, possible places. So it's nothing but probability of finding one with respect to many. Here we'll find, like we'll understand in a depth when we consider the formula. Sorry, when we consider the situation. Okay, so let us consider that there is one more ant, third ant. Okay, now it's moving from C1 and C1 to all other cities and coming back to C1. Okay, so how to find the probability of next edge to be taken? For example, if that S3 is starting from C1, then what is the probability of S3 going to C2 from C1, or going to C3 from C1, or going to C4 from C1? Okay, so to find the probability, we use this formula. Okay, so first we'll list down what are the possible ways from C1. Okay, so from C1 I can go to C2, C1 I can go to C3, C1 I can go to C4. This is based on the first graph, which was constructed based on the cost matrix. So there is a edge between C1 and C2, C1 and C3, and C1 and C4. Hence S3 can go either for C2, C3, C4 from C1. Okay, now it's a task for us that what is the probability of S3 moving from C1 to C2, C1 to C3, and C1 to C4. Okay, so this is a probability calculation where not S2, sorry, it's S3. S3 selecting C1 and C2. Okay, so it's a probability of C1 and C2 will be equal to the pheromone deposition between C1 and C2. You can see here the pheromone deposition. This is from previous table. Okay, I'll take this one and I'll calculate the pheromone deposition in that particular edges. Okay, so this is a pheromone deposition between C1 and C2, that is 0.60 into 1 by 4. Okay, so 1 by 4 is a cost, so 1 by 4 will be the value of the n here. Okay, so whole divided by all the possibility values. That is, first I'll write this possible, saying that 0.60 into 1 by 4 plus I'll write next this possible value, that is 0.53 into 1 by 15 plus, next I'll write this one, that is 0.57 into 1. So all the possible values with respect to C1 and C2. Okay, so I'll get this probability. It's like 0.1986. Okay, so similarly I'll calculate for others also, like your C1 and C2, C1 and C3 in the same way. Here it is a pheromone deposition of of a edge between C1 and C3 into its cost value, like 1 by cost whole divided by the total possibility. Like this is for C1 and C2, this is for C1 and C3, and this is for C1 and C4. So this is a total probability, like total possibility with respect to C1 and C3. So this is the value you got. Similarly, you'll find for C1 and C2, okay, C1 and C4. Okay. So when you put in a pie chart, so this will be the distribution where C1 and C4 take 75%, and PC1 C2 takes approximately 5%, and C1 and C3 takes approximately sorry, this is C2, this is C3, this is 5%, and this approximately 20%. Okay, so this is a distribution. So from this distribution you can see that there's a high chance of a salesperson S3 or ant, third ant, move to C4 from C1, okay, based on the pheromone deposition. Okay, so there's a high chance. Okay, there's another method, like we can use a roulette wheel also, okay, to find the next probability of edge. So how to find in roulette wheel is, okay, first what we do, we calculate the probability, same like this is what, these are some probabilities, and for that we calculate the cumulative probability, and then what we does is, whatever value we get from roulette wheel, we'll just put in a comparison. If that random value, that whatever value you get in roulette wheel, it is considered as, that is random number. If the random number lies between this cumulative ranges, then we'll say that it will either belong to C1, C2 or C1, C3 or C1, C4, and then we'll conclude based on this range. Okay, so this is a probability which written exactly from the previous value. Okay, so cumulative probability is a one which has the addition of the previous one. For example, see here in this diagram, for example, see here in this diagram, okay, so here C1 and C4, okay, so we'll write the probability. C1 and C4 probability is 0.5, okay, so I'll write exactly as 0.5. So I'll start from this and then I'll move to this side. Okay, so next will be C1 and C3. So the next edge is C1 and C3, from we'll go like this, okay, clockwise. So C1 and C3, so you have some probability for C1 and C3, that is 0.05. So in cumulative what you do is, you will add for this path, the previous path, and then you'll make it as a new probability. That is, the previous probability was 0.75 and I'll add this, so 0.05. It will become 0.8. Okay, similarly, then in clockwise, the next edge comes as C1 and C2. So C1 and C2, so it is like 0.20. Okay, so I'll add this for previous cumulative probability. 0.8 with 0.20 will be 1.0. So this is how it goes. Okay, if there was path here something like a Cn, then when I'm considering this cumulative probability, I'm supposed to add to the previous cumulative probability. So in short, it tells that the addition of a previous cumulative when it moves on right side, like when it moves clockwise, then the cumulative probability will be the addition of a previous cumulative probability with the actual probability. Okay, so this is how cumulative probability is done. Now when in a roulette wheel, like if I get some R value, that will be a random, since we know what is a roulette wheel here. So whatever value we get will be a random value there, and we'll check if the random value lies between 0.8 and 1. So 1 or less than 1 or 1 between 0.8, then it belongs to C1 and C2, means C1 and C2 is considered, okay. Or else if the random number lies between 0.8 or equal to or less than 0.8 and 0.75, then the probability C1 and C3 is considered. Or if the random number is equal to 0.75 or less than that until 0, then it probability of C1 C4 is considered, okay. So that's how we construct this. And now we'll see, in general sense we know that the chance of random number being between 0.75 to 0 is higher, because here the range is higher than all other range. So most of the time the R lies between 0.75 and 0. It has a high chance or high probability. Hence there is a high chance that S3 gonna select C1 and C4, okay, because most of the random numbers might lies between this range, because it has a huge number of range, okay. So it tells that there is a high chance of selecting C4 from C1, okay. So the and 3 will select the C4, okay. Once it select the C4, so it goes in a similar process for selecting the further one. So this gives a optimal solution, okay. So this is what like I understood, and based on the materials which I received, like the based on the materials I received, okay. But I don't know whether it is exactly right answer for this particular question or not. Even I tried, but unfortunately I couldn't find a good answer for this, that is an expected or satisfied answer. But yeah, this is what I got. Thank you.